The 18th question says, find the image of the point 3, 8 with respect to the line this, assuming the line to be a plane mirror. Oh, pretty interesting. We have a line which is x plus 3y equals 7. We have a point P, and considering this as a plane mirror, we are supposed to find the image of P. Okay, P is 3, 8, and if you want to find the image, let's call this point alpha, beta. If you want to find the image, can you observe that the line segment PQ, for image, the line segment PQ, if this is the incident ray which is just perpendicular to the surface, the point Q will lie on that incident ray only. Reflected ray will be this, right? This is the incident ray, this is the reflected ray, this is the reflected ray, and just behind that will be this particular point. This distance will be this distance, and this line will be perpendicular. Now, if this is a plane mirror, you will have many such lines, but I am considering that particular line which is perpendicular to the plane mirror, and yes, Q will lie on that line only. Yes or no? That's a special thing, right? Okay, so for plane mirror this happens, and once this happens, then now we can comment on finding the values of alpha and beta somehow. How do we find that? For that, we'll need this foot of the perpendicular. In one of the previous questions, in some exercise, we had found this foot of the perpendicular for this point P, and after solving the basics, I had given you one formula as well over there. So here also what we'll do is we'll solve using the basic concepts. First of all, at the end of the day, at the end of this particular solution, I'll also give you one formula for finding alpha, beta directly as well, right? So let's talk about this alpha and beta from the basics. So what you'll do is, for alpha and beta you have two unknowns, so you'll need two conditions. And do you see that I have those two conditions over here? The midpoint of PQ is M, which lies on this line. That's one condition. And the slope of PQ, slope of this line are perpendicular, right? These are perpendicular lines. The product of the slopes will be -1. That's the other condition that we have, right? So let's use this. This is M1. M1, the slope will be -1/3. You can check that slope, right? Okay. And M of PQ. So M1 times M of PQ will be equal to -1. This is one of the conditions. Okay. So for this, we'll need M of PQ. Let's find M of PQ first. M of PQ is pretty simple. This is beta minus 8 upon alpha minus 3. Is that okay? Yes. So I can multiply that with M of M1, which is -1/3, and make the product -1, and I'll get one relation between alpha and beta. So therefore 1 gives me beta minus 8 over alpha minus 3 times -1/3 is equal to -1, which tells me, okay, -1 gets cancelled, and this 3 times alpha minus 3 goes over there. This is beta minus 8 is equal to 3 alpha minus 9, which tells me beta equals 3 alpha minus 1. This is the equation obtained from 1. This is 1a. Let's call this 1a, not 2, because we need the second condition, right? The second condition is the midpoint M of PQ. Can we find the coordinates of M? Yes. This is alpha plus 3, x1 plus x2 by 2, x1 plus x2 by 2, and similarly y1 plus y2 by 2. This lies on x plus 3y equals 7. This is the second condition actually. And using the second condition, we can find the second equation. Therefore, using second condition, we can find the second equation. What is that? Let's put this point over here. Alpha plus 3 by 2 plus 3 times beta plus 8 by 2 is equal to 7. This is what I have, right? Can we simplify this further? Yes, we can multiply by 2 throughout, and this becomes alpha plus 3 plus 3 beta plus 24 is equal to 14, or this tells me that alpha plus 3 beta plus 14 is what I am getting. Is it 13 precisely? 13 is equal to 0. This is the other equation between alpha and beta. This is, let's call this 2a. Since it has been obtained from the second condition, let's call this 2a. Right. So now I can solve using 1a and 2a. I can get the values of alpha and beta. 1a, okay, let's use 1a and 2a combined gives me that alpha plus 3 beta will be 9 alpha minus 3 plus 13 is equal to 0, which tells me 10 alpha plus 10 is equal to 0, which tells me that alpha is equal to -1. Okay, and beta will be 3 alpha minus 1, which is minus 3 minus 1 minus 4. And yes, therefore image of this point will be minus 1 comma minus 4. That is my answer for this question. Yes, that's the final answer. Yes, that's the final answer. But this is using calculations concepts, right? And using basic conditions, that's all. Using slope, midpoint and all. But do we have a direct formula? Yes, we have a direct formula, and that formula is similar to the one we saw for foot of the perpendicular. Let's say we have a line L, ax plus by plus c equals 0, and we have a point P, x1 comma y1. We want to find the image of Q. This is, let's call this x3 comma y3. Why not x2 y2? Because we used x2 y2 for this m, right? Okay. So for finding this image, what we do is x3 minus x1 upon this a is equal to y3 minus y1 upon this b is equal to minus 2 times a x1 plus b y1 plus c upon a square plus b square. Mind you, there is no under root, there is no modulus over here. There is no modulus, there is no under root. This here is minus 2. Take care of this. And yes, this is the formula. So along with this, if you find this one, you can use first and third to get the value of x3. You can use second and third to get the value of y3 in this manner. In that formula, for x2 comma y2, you had x2 minus x1 upon a, y2 minus y1 upon b. Here, instead of minus 2, you had minus 1, and rest everything was same. Rest everything was same. Right? So the formula for m and q are quite similar, and you can use for competitive exams, you can use these formulae directly. Otherwise, you have this whole method, and we are good to go with this as well. Right? That's the complete solution of this 18th question for us.